Hello, we are here with a Delta solution, and this time I've got Charles Tan, a software engineer here at DeltaStream. And what we're going to do is show how DeltaStream can connect to data, manage some data, and write it out to Snowflake. And we're going to do something then over in Snowflake. How you doing today, Charles?
Good. Thanks. How are you?
Excellent, thank you. So with no further ado, why don't you go ahead and kick us off, share, and let's go from there.
DeltaStream's website signed up for a free trial and brings me to this page. This is basically a fresh DeltaStream organization. So what comes with the free trial is if I go to Workspace, there's a trial store. This is basically just like a Kafka store that we just bring up for you for free. And in here, there's a few topics. We can print this one. This page views is what we'll be working with today. As you can see, this is kind of what the data looks like. This is the Kafka key, Kafka value, and then these are the fields.
Okay, so the user ID and what page IDs they saw.
Yeah, exactly.
Okay.
What we'll do is we'll create a stream that represents that data that we were just printing, that page views data.
Okay.
Streams need to go into a database and a schema. So that's what I was just doing there, was creating a database. So whenever you create a stream, there needs to be namespaced into that.
Okay, so this sort of is the official description of that data store.
Yeah, what the command I'm about to write would be the description of specifically that topic. So here I'm going to do create stream page views. And if you remember in the value, there were 3 fields: view time, user ID, and page ID. So this is kind of how I represent it. Using a statement like this. And then how do you know where this data lives? You can add this with statement and you can specify the store. So here is the trial store.
Okay.
The format of the data is JSON. That wasn't really shown very well in that other view because we kind of gave it into a table format, but I know that this one is JSON. And then last one would be timestamp. So the timestamp, since we're doing stream processing, we need to know what is the event time, and this field as the event time, and that's kind of reflected here.
Okay.
So after we run that, you can see that page views has just appeared. It used this database in this schema. This was the database I created earlier.
Okay. You expand to page views and that'll show the fields that you just specified, right?
Yeah, exactly.
Okay.
So after that, the whole goal is that we want to eventually take our data, which is currently in Kafka. We'll perform some mutations and we're going to write the data into Snowflake. So how do we connect to Snowflake? That would be another store. So we can add a store here. You can see the different options, and Snowflake is one of them. So this is the name of our Snowflake store. This is the region that our DeltaStream computation will run in.
Okay.
All right. Bear with me here. This URL represents my Snowflake account. This is the account identifier. So,
okay. So it's the location of our data and then our access control credentials.
Exactly. So the account ID, so this one actually is similar to the URL that was from earlier. The role name, so there's RBAC in Snowflake, and we need to know which kind of role are we using when we're communicating with Snowflake from our system.
Okay.
If we have to run any queries on the Snowflake side, we need to know the warehouse name. The user is just your username.
Okay.
And then this key file is a public private key that I had to create to associate with my Snowflake account, my personal Snowflake user with my Snowflake account. I had to generate a public private key so I can use that to do the authentication. I have the docs here because I figured that we may want to be curious, but basically in the docs, it goes over exactly how you'll do it. Using SnowSQL and OpenSSL, you can go and finish those steps to generate that file.
Okay. Yeah, pretty typical for that kind of thing.
Yeah. So now I've added my store. It takes a second for it to get ready, but now it's ready. and we can kind of inspect it. These are all the Snowflake databases I have. If we look into the demo DB, there's only a couple things. This is just a bunch of random data that we have, but I can add a new schema, for example. So I had one called test, and we'll use this and write to it later.
So that test schema now exists in Snowflake?
Exactly, yeah. So if I go to Snowflake, this is my Snowflake. I can look at my data. This is exactly the same kind of view. Test now exists here.
Yeah, cool.
Yeah, just now created. So
That was quick.
okay. So what do we want to do? I guess now I want to take a minute to talk about the goal of our problem. We have this page use data. This is coming in a Kafka topic, so it's continuously streamed. You can think of it as like if you have a website, you have a bunch of users, and they're just clicking on all the pages on your website. These are kind of the events coming out of there. We want to do some computation, and we want to store that in Snowflake. Now, if you didn't have a system like DeltaStream, what you would probably do is you would have a connector that takes your raw data from Kafka, writes all of it into a Snowflake table, and then does computation on that side. You can move that computation left using a stream processing engine like DeltaStream.
Shift left, yes.
Yeah. So what I want to show off in this particular example is we want to figure out for a particular user, we already have what page they visited, but we also want to see the previous page they visited. So we want to see what page they were visiting at what time and what page did they come from, essentially.
Oh, okay.
So let's build out this query. So let's just start simple. If we just select the 3 fields that we know exist, we can run this and it'll give us the results back in our console here. And it's used mainly for testing. This data, like the result set, is not being saved anywhere. It's just going back to the user so they can debug their queries before they go for a real one.
Yeah, that makes sense. It's convenient.
Yeah, okay. So you can see the results coming in. This is pretty much what we expected. It's very similar to what we saw from the print earlier.
Oh, yeah.
Now, view time, this is just like the milliseconds since Epic, I guess. So 1970 at that whole thing.
Yeah.
And it's kind of hard to know, like, what is this actually, unless you're very quick with math. So we can use a quick function to just put this into a better kind of view for us. This basically converts numerical Epic kind of values into a timestamp format. So let's try this again.
Yeah.
Go.
Nice.
This is a little bit better. Let's build on this and let's get the previous page ID that the user visited. So I have this query saved here. It's the exact same beginning. We added this column here. This is calling a function. This is one of our built-in functions. So it's basically the same as the SQL lag function. What it's doing is it's looking at the page ID, getting one value previous, and it's looking at this set of data. So it's looking over all the page IDs grouped by essentially the user ID, ordering by the view time, and just choosing one before. We're aliasing it as previous page ID. We have a whole bunch of built-in functions. They're in our documentation here. dsLag is the one that we're using. So ours, since we know that it's a varchar or a string, we can use dsLag varchar. There's all these kinds.
Okay.
Let's run this again. All right. So let's take a look at what we have here.
Nulls in some of those previous page IDs.
Exactly, yeah. So the idea for the null is that if you're the first one.
Previous one? Okay.
Yeah, exactly. So by default, we read from streams starting from the latest. So we just pick up new events. We also have other configurations where you can say like start from a particular partition offset or start from earliest. So we have a bunch of options in that. By default, we do latest. So that's why we see some nulls here.
Okay.
We can validate a little bit, like user ID 9, we can see a few in a row. So the page ID was 36 here, then it got 34, and the previous was 36, and then 83, and the previous was 34. So it seems to be doing what we expect.
Yeah. Not very much code, eh?
Yeah. So I'm going to add another field here. This is the same. You can see that this time I'm doing ds_lag on the big int because view time is a long, which we call big int in our system. And we'll convert the timestamp as well. And we're basically getting the previous timestamp. So what time did they visit the old page? What time did they visit the new page? We'll have all that.
Okay.
I guess I can run this one too.
Oh, interesting.
So this makes sense. This timestamp is 1 second later than this timestamp because this is the older one. This one makes sense as well. So
yeah,
once we're happy with our results, which we can choose to persist them into an actual data store. So here we want to persist into Snowflake. So we can change our select statement to be a create table as select statement. So here we're going to create a table, calling it page views with prev. With the previous. You can see I'm specifying the store as the Snowflake store, which is this. I'm telling which database and schema, so demo, DB, and test. And I'm even going to specify the table name, even though by default it will just inherit from here, but I'll be explicit this time and put it this way as well.
Okay.
That is all going to be the result of the statement that we just ran, that we were just testing with here.
So we're doing filtering and kind of combining really too, because you're taking that static stream and pulling information from the previous state, and you're going to put that into a table in Snowflake.
Yeah, exactly. Okay. And doing it this way, like we were talking about earlier, is a bit better because you don't have to run that computation on Snowflake and you don't have to store 2 sets of data because it would be more or less the same set of data.
Well, you're doing it in flight. So if you had to wait for it all to arrive and then do the computation, like it could theoretically never finish arriving. And in this case, you're doing it in flight and landing it in there, and you could have a dashboard that just keeps refreshing as things are coming in.
Exactly. Yeah. In the Snowflake world, the way that would have worked probably is you can set up tasks, and on a timed interval, you would get the diff, whatever has come in more recently, and try to run that all at once. But you're definitely introducing latency by that because you're doing it on a timer as opposed to whenever the event comes in, which is this method.
Yeah, not to mention the compute costs within Snowflake.
Yeah, that's true.
It's resources and money, right? If you got a bunch of these going and computing all that at the same time.
Right. So let me run this. After running this statement, you'll see that we created a query and a table. So this table is, since I'm stuck with the default database and schema, we can see that this table is just created.
Okay.
And this table, if we were to look at the details, we can see that maybe the metadata, we can see that it has this store, this Snowflake schema, this Snowflake database. That is referring to what was in here. So this was not here earlier. This one was created after I run this statement. We basically went to Snowflake, told it to create a table, and then we created a table on our end that represents that table. Yeah.
Cool.
And then as well as that, there's also this query that was created. So now we can see in the top right, we have a new query. We can actually inspect this one as well.
And that continues to run.
This is a long-lived query. Yeah, this is basically always running, and whenever new events arrive in the Kafka topic, it's picking this up, running that computation to get that last page ID, and then writing the result as a row into a Snowflake table.
Cool.
Yeah. It looks like it's running. Let me go to Snowflake.
We should have something there now.
Yeah. So now we have a table here. I think if I just do data preview, you can see, you'll see like there'll be some nulls at the beginning, but once you scroll down enough, once there are no longer unique user IDs, we only have 10 in our test data, then there can't be any more nulls. So that could be the end of the nulls, I would think.
Wow. That's pretty simple.
Yeah. And we can also get this kind of printing from our system as well. So you can also print from
So is that printing it from what's contained in Snowflake or what's in flight from us?
This is what's in Snowflake.
Okay, so it's actually reading from Snowflake.
Yeah.
Okay.
Yeah.
Well, that's really cool. Well done, Charles. Thank you for taking the time to show this to me.
Yeah, for sure.